All right, here we're looking at section 9.4, and we're going to be completing the square today. This is just another way that we can solve quadratic equations. So our learning targets for today are complete the square for expressions of this form x squared plus bx. Then we're going to solve quadratic equations by completing the square. Then we're going to find and use maximum and minimum values. And remember, we've talked about these maximum and minimum values, and this is where our vertex is. So then I'm going to solve real-life problems by completing the square. So the first thing I want to look at is when I have this expression x squared plus bx, I can add a constant c to the expression so that x squared plus bx plus c is a perfect square trinomial. And remember, I like perfect square trinomials because then I can factor them very easily. So this is called completing the square. So now here's my core concept, kind of explaining what we're doing. So to complete the square for this expression, I follow these steps. So first, I find 1/2 of b. So I divide this b term by 2, and then I square that and add that into both sides. But the thing is, I have to add it to both sides to make it mathematically correct. And we're going to see this over and over, so don't worry too much if you don't understand these words yet. And then I can factor it. So here's my justification. Here's kind of what it looks like in pictures. So the combined area, right, is x squared plus bx. And I see that this little green box is x squared because I've got x times x. That's x squared. And if this length is b, then I have b times x. So now what I'm doing, right, is I cut this in half, and then it moves down here. So now I have the same length on both sides. So I have x and b divided by 2, and I have x and b divided by 2. And now this little piece that's left over that I have to add in to complete the square, right, and I like squares, is this b divided by 2 squared. So now let's look at some math and an example. So complete the square for each expression, then factor the trinomial. So I want to take this, and I see that my b is 6 here. So I find 1/2 of that, so I divide it by 2, which is 3, and then I square it, which gives me 9. So now I can add that to that side, right? So now I have x squared plus 6x plus 9. So now I factor it. So when I factor it, you'll notice that this, this right here is the same as this number right here. And that's always going to be the case when I factor it. So that's always going to become this term right here. So now let's look at b. So x squared minus 9x. So my 9x here is negative, so half of that would be my negative 9 over 2. And I want to leave it as fractions. I don't want to simplify it, and I don't want to turn it to decimals. I want to leave it as fractions. So now I square both of those, and then I add that in. So I've got my plus 81/4. Now I can factor it. And here you'll see that this negative 9 over 2 becomes what I factored it into. So now I've actually completed the square and factored both of these. And this is going to come in very handy when we start solving again. So now try these, see what you can come up with. So now let's go ahead and solve this by completing the square, right? So before we just completed the square, now we're actually going to solve. So the first thing I want to do is write my original equation, and then I'm going to complete the square. So I divide this by 2, and I square it. So here, when I am adding this c term, this red constant term in, I have to add it to both sides of the equal sign. Since it is an equation and I have to mathematically keep it accurate, I need to add that to both sides of my equation. So now I can factor this left side, right, and this negative 8 becomes this term here, equals 49, because I've got negative 15 plus negative 8 squared is 64. So now I can simplify this right-hand side. So now that I have just a more simplified something, a binomial squared on the left, now I can finish solving. So I take the square root of both sides. And remember, when I take the square root of a number, I have the plus and minus, the positive and negative roots, and then I simplify by adding 8 to each side. So 8 plus 7 is 15, and then 8 minus 7 is 1. So my two solutions here would be 15 and 1. So now I have to double check, because sometimes solutions don't actually work out. So now I just take in both my 15 and my 1, and I plug them back into my original equation. I substitute, and then I just do the math and simplify, and I see that both of these do end up giving me the correct answer, so I know that both of these are my solutions. So now here's another one that we need to solve by completing the square. So the first thing I notice is that this term, this coefficient here with my x squared term, is not 1. So that has to be the first step that I do. So I add 8 to both sides, right, because I want just this over here on this side. Then I divide everything by 2, right, because I want to get this to be a 1. So divide everything by 2, so now I'm left with x squared plus 10x equals 4. So now I complete the square. So remember, to complete the square, I divide this by 2. So I'm going to end up with x squared plus 10x plus this divided by 2 was 5 equals 4. And then I have to add this to this side as well, right? Because I'm adding this over here. Oh, wrong color. There we go. I'm adding over here, so I have to add it over here. So mathematically, I'm doing really nothing, okay? So we got our 5 squared. So now I can factor this left side and simplify my right side. So my left side factored is that 5 comes down here, and this becomes 29. So now I take the square root of both sides. So I end up with x plus 5 equals plus or minus the square root of 29. And I want to leave this as the square root of 29. Since I don't know what that is, I don't want to put the decimal values. I want to leave it just like this. Then I subtract 5 from both sides. So this would be my final solution. My final solution is this negative 5 plus the square root of 29 and negative 5 minus the square root of 29. Sometimes you'll be asked for the decimal, and if that's the case, then you can go ahead and put this in your calculator and find the decimal. But if not, go ahead and leave it as this full exact form. So now try these and see how you can do with those. First thing, remember, you want to get that term, that coefficient with your x squared to be 1, and then get the constant over to the right side. Then you can complete the square. Now we're going to be working on that next learning target of finding our maximums and minimum values. So here we need to find the minimum value of y equals x squared plus 4x minus 1. Now remember, you've done this before using our negative b over 2a. And then plugging that back in and finding that y value, and that also gives us our maximum or minimum, so we can do this multiple ways. Okay, so first I want to write this in vertex form. So I write my function, I add 1 to both sides, right, so I get my constant over there. So now I'm going to complete the square over here on the right side, right, where my x squareds are. So I complete my square over here, and then I simplify. So I end up with y plus 5 equals x squared plus 4x plus 4. And then I write my right side as the square of my binomial, right? So I factor this trinomial out. Then I subtract 5 again from both sides. So now I'm in vertex form, right? So before, when we found vertex form, I did my negative b over 2a and I plugged it back in and I found my vertex and then I wrote it in vertex form. But I can complete the square and do that to also write this in vertex form. So my vertex is going to be my negative 2, negative 5, and because my a was positive, right, the parabola opens up, so I know that it's a minimum value. And so my minimum value is always that y value of my vertex, so that's minimum for this function is that negative 5. So now here let's find the maximum value of this function, and I know it's going to be a maximum because my a value right here is negative, so I know that parabola opens downward. So again, I want to rewrite this in vertex form. So the first thing I do is I write my function and then I subtract my constant from both sides, right? So I'm left with this negative x squared plus 2x by itself on the right side. So the first thing I want to do is I want to factor out that negative 1, right? Because anytime I complete the square, this a value with my x squared has to be positive 1. So I factor out a negative 1 from this right side, and now I can complete the square. The big things to remember here is don't forget what goes inside my parentheses and that this negative 1 doesn't go away. So what you'll also notice here is that, yes, I'm adding 1 right here, but I have this negative sign here. So on my other side, I have to subtract 1. I can't add 1 over here because that will give me a different value because I'm really adding a negative 1 with this negative sign here. Don't lose those negatives. So now I can simplify the left side, and then I go ahead and I factor my right side. So I have a negative out front times x minus 1 squared. And now that I have this, now I can get my y by itself by adding 8 to both sides. So now I'm in vertex form. And again, my a value is negative, so I know that it opens down. And I see that my vertex is at 1, 8. So my maximum value is going to be that 8. So try this. So first figure out, is this going to be a maximum or a minimum? Then figure out what the value is of that maximum or minimum. So now we're going to be looking at this graph just to see what we can look at here. And we want to compare some graphs. Okay. Which of the functions could be represented by the graph? Explain. So the first thing I notice is that this parabola opens downward. So my a value is going to have to be negative. Okay. So the other thing I notice is I don't know the scale of either axis. So I can't determine just based on numbers alone. So I have to look at the characteristics that I'm given and figure out what I'm looking for. So the first thing I see is my vertex is up here in the first quadrant, and both of my x-intercepts are positive. So, and it also opens down, which we said. So it's got a maximum. So if I look at this first function, if I see the vertex, my vertex would be negative 4, 8. And I know that that's not in my first quadrant, so I know it cannot be this first function. So now let's look at this g of x, this second function. Well, it opens down, so that's good. That's a possibility. My vertex would be at 5, 9, which is possible. Okay, so this is a possibility, so I have to go a little bit further. So I solve it, and I can solve it by using my square roots, right? I see that my intercepts are 2 and 8, so this is a possibility. So let's look at m. So m has 2 positive intercepts, but it opens up because I don't have this negative out here, so I know that it can't be m. So now let's look at this p of x. This p of x has 2 positive intercepts, right? So my intercepts would be 2 and 8. It has this negative out front, so it opens down. So this could be it as well. So it could be either g or p. And that's all I've been asked to find so far. I don't have to find the exact one. I'm just looking at the characteristics of these equations and my graph and comparing them. So my graph could be either g or p. So now let's look at kind of a real-world example. So my function y equals negative 16x squared plus 96x represents the height in feet of a model rocket x seconds after it's launched. Find the maximum height of the rocket, and then find and interpret the axis of symmetry. Okay, so first I see that I have this negative here, so it's going to be opening down, and I have to find the maximum. Okay, so I want to write my function. Then I factor out this negative 16 from this right side, because I always want this with my x squared to be 1. So now that I've done that, I can go ahead and complete the square, right? So I divide this by 2 and square it. But see here, you'll notice that I'm adding 9 on this side, but I'm not adding 9. I have to multiply that 9 times this negative 16 to get my negative 144 that I add to my other side, right? And it's negative because this negative 16. So when I factor something out of my right side when I'm completing the square, I have to multiply that by what I'm adding in so that I'm mathematically accurate. Okay, so now I factor this piece and I add my 144 back to both sides. So I'm writing it in my vertex form. So now my maximum I see is 144. My model rocket reaches the maximum height at 144 feet. So now I was asked to find and interpret the axis of symmetry. Well, I know the axis of symmetry is x equals 3 because that's my x value of my vertex. So now I have to interpret it. I have to tell what it means. So on the left side of x equals 3, so from the time I release it to x equals 3, the height increases. And then on the right side of x equals 3, the height decreases. And I could kind of draw that out to see that as well. But I can just use my knowledge of what a parabola looks like to kind of explain that. So now here's a couple more that I want you to think about and try and see what you can come up with. So here's our last example we're going to look at. So you decide to use a chalkboard paint to create a chalkboard on a door. You want the chalkboard to cover 6 square feet. and have a uniform border as shown. So it wants to be pretty and even on both sides, on all sides. Find the width of the border to the nearest inch. Okay, so first we have to figure out what we're looking at. So I see I know the entire area and the length of the door, and I see that my chalkboard's going to fit in the middle, and the width of each border side is going to be x. Okay, so now x is going to be the width in feet, so I know the area of the chalkboard, right, this little piece that I'm painting in, equals the length of the chalkboard times the width of the chalkboard. Right, and that's just how I find area of a rectangle. So now I can solve in the things that I know. So my area is 6. The length of this chalkboard is going to be 7 minus 2x because I have an x on this bottom side. I have x here and x here. So I've got 7 total minus this x and minus this x. That's where I get my length from. And my width, the entire door is 3 feet, and I want an x on both sides, so it's going to be 3 minus 2x. So now I just write my equation from that. Then I multiply these binomials, right? All I've done is multiply this right side. And then I subtract 21 from both sides because I want to get only my terms with an x over on the right side. So I subtract that 21. So now I divide everything by 4 because I wanted to get this term to be 1. So now that that's 1, I can complete the square. So I divide this by 2 and square it and add that to both sides. And now I can simplify my left-hand side, right, by just combining my fractions. And I can go ahead and factor out this right side. So write it as the square of a binomial. So now I take the square root of both sides, and since I don't know the square root of 5 over 2, I just leave it as plus or minus square root of 5 over 2. And now I can add my 5/2 to both sides. So my solutions are, and I'm going to go ahead and put this in my calculator. When I'm dealing with real-world problems and word problems, most of the time I want to know kind of a decimal approximation. So I plug those into my calculator and I get my 2 possible solutions. So then I have to look back and make sense of this. So it's not possible for the width of my border to be 4.08 feet. Because let's look back up here. And I know that x is the width of my border. This little piece cannot be 4 feet because the entire door is less than 4 feet. So that solution doesn't make sense. So the width of my border is going to be 0.92 feet. So I can convert that to inches. So my width of my border is going to be about 11 inches, right? So I can do that using just the information that I know. And I'm told to do inches up here is why I converted it to inches. You don't always have to, but make sure you look back at the question so you know exactly what you're asked to do. So now, using kind of that example that we looked at on the previous page, try this and figure out the width of the border to the nearest inch. So now let's look back at our learning targets. Our first one was to complete the square for expressions of the form x squared plus bx. Then I have solved quadratic equations by completing the square. Then I had to find and use maximum and minimum values. And in order to find these maximum and minimum values, I could rewrite my equation in vertex form by completing the square. Then I looked at some real-life problems and solved them by completing the square. So now that we've gone through all of these learning targets, go ahead and work on your homework for 9.4.